we present OpenMic, a video conferencing tool that supports 2D spatial cues for turn-taking. Turn-taking describes the flow of participation among speakers in a conversation over time. We can imagine two speakers alternating their speaking turns with each other. However, multi-party conversational structure is much more complicated. When a third speaker is introduced, the next turn is no longer guaranteed to be a specific non-speaker. For example, this user can either talk to a user or address someone's point, or speak to the whole group. What made it even more challenging in remote meetings is that current video conferencing systems lack the support of subtle visual cues, such as someone wanting a turn at talk or whether other group members is paying attention to a potential bid to talk. There were some media-based work utilizing some proximity cues such as head turning and directional gaze cues to support turn-taking. However, such systems require specialized equipment, which is not desirable in the current trend of remote work that relies on everyday devices, such as laptops. What is most close to our work is the 2D virtual spaces that support proximity cues. For example, gather towns support users to form a group based on their distances. Such 2D virtual spaces were used mostly for leave-taking and approaching to improve user experiences into and out of conversations. For example, recent work explores the benefit of using proximity cues for conversation transitions during different moments of meetings, which can be pre, post, or during meeting for social purposes. Though there's work that utilizes proximity cues to support conversation transitions, there is a need for understanding proximity metaphors in a focus group for turn-taking needs. Hence, we look at the proximity theory to describe how social relationships can be affected by the user's spatial organization, such as forming different interpersonal distances. We draw two notions from the proximity theory to design new mechanisms for turn-taking in multi-party remote meetings. First is support fixed and semi-fixed feature space. We are in a material world. The fixed and semi-fixed feature space describe how furniture and built space can help and take part in our opportunities to enact our social relationships. For instance, rearranging tables can affect how people have conversations around them. And another example can be the lecture halls that lay out this social spatial order regarding who is in power to talk and who is listening. In this work, we focus on the fixed feature space. As you can see from the video, both users are moving their videos from the peripheral area to the central area, which we named the virtual floor. The floor edge defines the control of unmuting and muting the microphone. The whole view is the same for everyone, so that everyone can be aware of their spatial relationship with each other. The virtual floor presents our first interaction concept that as it serves as the fixed feature space for users to be aware of others' intention to talk and define a boundary for managing conversations. We have this open floor area where users can join it freely by moving their video on and off the floor to take speaking turns. We consider the increasing group size requires more moderation so that we create this moderated mode with a thick boundary around the floor. When the user initiates this moderated mode, the floor edges serve as a closed boundary, and all the users on the floor will become moderators. When the audience moves her video feed to the boundary, the speaker can click her video feed to grant access to speaking. The second notion is the perceptual cues for proximity. This can be understood as moving closer to show intention to engage with others, which is the interpersonal distance. In particular, the perception of proximity distance can include the image size. For example, mirror space shows how people lean towards the interface to show that they are very intimate to each other. Hence, we designed the malleable mirrors where we simultaneously transform the position and scale of the video feed when the user is on the floor. The malleable mirror can also be reshaped when the user moves from on-floor to off-floor. Here, when the user is off-floor, we want to maximize the view of the participant's face and minimize the space to the periphery of the floor. And the rectangular shape is supported for conveying hand gestures for speakers. Moreover, we support users to rehearse their behavior without being observed by others. For example, if this user drags his video feed without a mouse-up event, others will not see his behavior. We want to understand in study is how people will use virtual floor and malleable mirrors to interact with each other and how these features enable novel turn-taking behaviors. We conducted studies in 4-person group and 8-person group. The 8-person group will first break out into 2 4-person groups, and they will have some warm-up tasks and a survival task where they need to share their own choices with the share screens and negotiate and collaborate with their remote peers. And the 2 4-person groups will later convene to an 8-person group and present their group choices to another group. And there would be a Q&A session where the audience group could ask questions. Here, I present several key findings of the study. The first set of findings is about the use of virtual floor. Participants were aware of their personal space when on the floor. As you can see from the figure, when the user is switching from off-floor to on-floor, their behavior is that they will move to the space first and reserve their video there temporarily without going further. During the focus group interview, users mentioned that they consider the floor as an open space for more people so that they can leave spaces for others. In contrast, when off the virtual floor, we observed that the participants tended to stay at the initial entrance position, and sometimes some of them will overlap with each other without noticing. They did not move their video feeds unless they intended to take turns on the floor. During the focus group interview, they mentioned that they would like taking seats in the dimmed area or around it, which may indicate that the structured video placement like Zoom might be suitable for audiences. However, they appreciate the flexibility of OpenMic's unstructured video placement when it came to taking turns, allowing them to resize and reposition their video. The group size may affect the use of floor boundary. In 4-person groups, participants keep themselves on the boundary and maintain the conversation flow for a long time. While in the 8-person group, they kept entering and leaving the floor to actively engage in the conversation. During the focus group interview, a participant mentioned that his interpretation of the space in the 8-person group is like standing up in the classroom. The second set of findings is about utilizing malleable mirrors to enact turn-taking behaviors. First, users use relative position for turn-taking. Off-floor participants took the floor using the shortest path to the virtual floor. This shows a turn-taking pattern where audiences reversely adjust the whole presenter group via the boundary of the virtual floor. In contrast, 2 participants moved to the boundary in close relation to someone to adjust the person. This shows the difference between adjusting the group and adjusting the individual. Resizing the video can also convey the intent to hand over the floor. In this figure, the speaker tried to hand over the floor verbally with, "I guess if someone agrees, we can put 1 and 4 and the seat cushion, right? That will work?" And other group members responded by nodding their heads. To reinforce his intention, the speaker moved closer to the center of the floor and enlarged his video feed, saying, "Yeah? Or I will just put it in the sheet." Other group members started to enter the virtual floor and contribute their ideas. During the interview, it was mentioned that initially some audience members did not fully understand the speaker's intent to hand over the floor. However, they later picked up on the visual cue of the speaker, enlarging his video feed, and understood his point. To sum up our findings, we have identified 4 types of turn-taking zones that users utilize to partition the virtual space during multi-party video meetings. These zones include the audience zone, near-edge zone, transition zone, and center zone. These zones play a crucial role in facilitating gradual engagement with other participants in the meeting. The near-edge zone serves as a temporal peripheral zone where participants position their video feeds on a smaller scale closer to the boundary. Movement in the transition zone reveals diverse and rich interactions that are categorized by subtle proxemic cues. As participants move across the center zone, it signifies a change in conversation state, which some active speakers may utilize to take control of the conversation. When used in moderation, relative position can serve as a cue for addressing either an individual or a group during the meeting. In summary, utilizing Proxemic metaphors can support better conversation flows. The use of floor and malleable mirrors can enable a central attentive space. Users utilize the size and position of malleable mirrors to enact different speaker roles. Thank you for your attention.